So if you don't know me already, my name's Emir Turkes. I'm a PhD student in Karen Duff's lab. And I work on bioinformatics there, and I work extensively with R. So, considering that so many people are moving to, more computational things during this time, we figured it'd be, kind of nice to maybe do a little tutorial, a little Q&A, exchange some ideas. So, yeah, I hope this will be fruitful for everyone. And if anyone has any questions or anything, just feel free to stop me at any point. So that said, if there's nothing else, I'll start sharing my screen and yeah, get to it. Okay, so you should be able to see my screen now. Kind of want to close my video to speak. Oh, it'll be all right. So, right. So as I mentioned, I'm a PhD student here. And so this talk is going to kind of cover broad aspects of R. I'm trying to avoid going into like the nitty gritty technical details because everyone's, analysis, everyone's projects, differ, but I tried to select things that I think are generally applicable for everyone, especially project management and organization of your tools and code so that you don't have a headache and mess down the line, because that can really happen and it'll slow you down. So, starting with the obligatory what and why, what is R and why are we using it? So R is a free and open source statistical programming language. It dates back from 1993, but derived from an older language, S, which is from the late 70s. And it can be found on the CRAN website. That's the main source, but I'll talk later that there are other distributions of R, actually, and they, could be considered. And so why should we use it, right? So R has a very active ecosystem, and it's actually the reference implementation of many statistical methods, primarily newer ones. And this is quite important because, sometimes different people quarrel about, which language is the best, what should I use for my analysis? Well, R is a language that a lot of statisticians like to use when they put their, new statistical methods into code. So I would consider that, as a high quality source for using statistical methods. And programming language in general offer a very high level of reproducibility, documentation, and flexibility. And on that note with flexibility, so I did something interesting with my slideshow today. You can actually code it in R. So this is using R Markdown, using a package called Reveal.js, which incorporates JavaScript, and you can get some nice presentations, incorporate code. So very interesting things you can do with R. Remember, if any questions, just feel free to stop me. And so how would we use R? How do we get started with it? So I mentioned there are several distributions. They're all free. CRAN is the primary one, and the one, I assume everyone is using. And I recommend that if, you're just starting out. Doesn't have any additional special features, but, it's already feature rich on its own. Microsoft actually has their own distribution of R. And so this is interesting because it's actually faster. It incorporates these mathematical libraries that, are standard across, many different methods. So it links to these libraries and you can get a speed up in your analysis. And they also snapshot their version. So they have better, so if you need to use a specific version of a package, Microsoft OpenR is quite good for that. And because of that, it has become like the default in Docker, which is, their Docker is a type of container, and those are good for keeping a reproducible analysis. You have your own environment for doing the analysis for each project. So yeah, that's good for controlling your versions and for speed. They don't currently have a Mac OS version, so that might be a no-go for some people. And I notice the site goes down kind of frequently because I use it with Docker, and I've run into it, trying to download something and the site's down. So that's, that's frustrating. And Conda, so people who use Python would be familiar with Conda. It's, primarily built for Python, but they have R packages for it and a strong virtual environment system. But I haven't used it personally. I've heard it's a bit buggy in some ways, and it's the least official approach. So, and as far as IDEs, so this is where you'll actually do your programming in. It's, you know, point and click kind of interface. RStudio is the gold standard, and I can't even recommend any other IDE. There are a few others, but RStudio just kind of blows everything out of the water. And they have a free, there is a paid version, but it's really, that's just for like corporate use, licensing and things. And it's organized. It has this nice, you know, quadrant system here that works very well. And so last slide before I move on to, you know, some actual code, some more interesting things. These are some resources I've compiled that have been very, very helpful. A couple of them, I mean, so I'll be distributing these slides afterwards. If you're interested in R, I recommend, you know, just clicking on each of them and, you know, seeing if they might be helpful for you. Some are tailored towards like single cell transcriptomics analysis, but they have general R tutorials contained within that are actually very good. And these authors are all very reputable. Hadley Wickham, for example, he's a key player in the field, key developer, so all good people to follow. Any questions so far? No? Okay, I guess we're good. So the next thing I want to do is actually, so go into RStudio. And so I assume most people here have, if you're interested in R, maybe you've tried RStudio already. But so, for example, I'd been using R Markdown a lot. And so you can see here, this is the Reveal.js, you know, presentation. I made the slides here. So you can do that kind of stuff directly within R. And, you know, all that stuff works. So it's an interesting option to do that kind of stuff. You know, you can, it runs and loads and all that. So, but starting at a very basic level, so, you know, I put together these just very straightforward examples, I think, just to get a feel of, you know, what it's like to, you know, program your analysis. And this is just kind of, you know, warming up, I suppose. So, right, in R, so we use this specific syntax for assigning, but you can use the equal sign. That works fine as well, but this is more conventional. And oh, so I'm gonna actually put on, so keyboard tracker. This is kind of neat, actually. So just to see, you know, what I'm typing into the keyboard, because there's some very handy keyboard shortcuts that can make things quite quick. So yeah, Control S is to save your document. If you do Control Enter, you can run line by line. And this is quite nice for going through your document. And right, so we have these three variables on the right, and there's a number of different ways to notate them. You can use this exponential notation, which is very handy. And if you have a decimal, but it's 0, you know, they're all equal, and you can test that. And so this is what that kind of syntax looks like. And so this is a test for equality. If you know, ever need to search that, Google search it, you know, test for equality. And this is considered the AND operator. So what we're saying here is X equal to Y and Z? And they are, right? We do a little arithmetic. If we add, you know, a decimal to Y, now we see that that's not true. Oh, so I should have pointed out, we should be looking on the bottom left here in the console. Here you can directly, you know, type in commands. And when you evaluate things, it's returned here, at least when you're just using a regular R script. So right now that's false. But if we use the OR operator, now that's true. And this is useful for if-then statements, which I'll show a little bit later. And you can also put strings together. Strings is what we refer to as, you know, these characters, things that are not numbers. And paste is a very handy command. So of course, I'm being a little arbitrary in what I'm showing here, because really there are many things you can do in R, so it would be impossible for me to go through all of them. So those resources are handy for getting, you know, the full, full overview of all the things you can do in R. But simple example, so you can paste each of these words together. You can index 1, 2, 3, and you get a little sentence. And G sub is another useful one. And so you substitute is with isn't. So you see that's changed now. Grepping is when you pull out certain words or certain patterns within some kind of data structure. So this time we're pulling out great out of R isn't great. We can get, so it's the third position there. And if we plug in the third position of words, so this is the kind of things you do a lot of these kind of manipulations when it comes to programming. And here's maybe a little more concrete of an example. Like, let's say we want to make a data structure. There are useful things, useful commands for that. You can make a sequence from 1 to 3. And you can repeat a number, 3 times. So there's all these handy, commands, these functions, and you can make the reverse one of these. And then you can make, so this is a data frame. There's a number of different data structures within R. This is just one of them. And in RStudio, it's very nice. You can just click on them. Now you get the column names and you get the values. For these, so you can't click directly, but there's if you type in directly, then you can, take a look at it like that. And just some quick manipulations, you can do that. You can get the sums of each column in data. Get the mean. There's a whole variety of things, and some handy built-in functions and whatnot. And so this is what a plot would look like. So yeah, that shows up in this plot pane, and from there you can export it, zoom in on it, all handy stuff. You can take the transpose of a matrix, so you can flip the X and Y axis. And finally, if you're working with large amounts of data, it's good to clean up your variables and your structures, because then you might run out of memory depending on the machine you have. Just clean that up, and if you hit, and GC is also handy for just actually clearing space in your machine. So those are just some basic things, not really directly related to biology, but working your way around the language. So I recommend, if you're totally new to R, maybe try going through some tutorials, doing these kind of things, especially this section here, building a data frame, manipulating it. There's actually some interesting things you can do with that. So, right. So, any questions so far? Anything? Okay. Yeah, sorry if this part's kind of dry, but it's gonna, start picking up. And also, coming back to this here, so this is an R markdown. If you haven't done this before, so the very handy shortcut here is to, you knit it, basically. You do Control-Shift-K. And then now, so that created, so now we have a new slideshow, right? Because mine was actually open here in my browser, but it made a new one. So you can just make, new documents on the fly, and it contains all your code and everything. I highly recommend getting into R Markdown. I think it's really the way forward. And right. So I'm gonna turn off this keyboard thing for a sec. Okay. So moving on to the next thing. So right, going back to this, these slides that I have here, I want to talk a bit about project structure. Actually, I think this is one of the most important bits of this talk, because this is something I'm personally very interested in, how you build the right infrastructure for doing complex analyses. So I made a template that I'm going to be distributing to everyone. It's already ready. It's on GitHub. And so this contains what I feel everything you need to start an analysis in R in my opinionated best practices. It is opinionated, but I have a variety of methods for running your project and organizing your packages and making sure when you send your analysis to someone and they want to run your analysis, they can. And so there's a number of ways, you know, running it locally, through Docker, and through Singularity. So all those files are here. I tried to comment them where I could. Maybe I'll add more comments later, or you know, you can ask me any questions about it. But right, just to get, you know, a look at what this you know, project template looks like. If we look at the directory structure, it looks like this. So I always define like an assets directory. So these are binary files. They're not code, they're data. And you don't put these into Git. There's a lot of, you know, best practices surrounding Git. Git and GitHub is kind of a tricky tool. And I can't say I recommend it for everyone because it requires time investment. It is a good tool, but it's a bit complicated to use. Long story short, data and things do not go in Git. I have, you know, Docker related files. You want to ignore certain files in Docker. This is the whole Git directory. Git, right, I didn't even say what Git is. Git is a tool for tracking changes in your code. It's a backup tool. You can, you know, obviously you are backing up your data by tracking your changes, but it's primarily for seeing, you know, how your code changes over time. So if so the most recent thing I did here, I added a comment, right, for my README. So you can see how code changes over time, revisit older versions. Stuff's quite handy. License, open source licenses. R code, typically put in one directory, but then I nest it for each, you know, analysis I'm going to conduct. This is actually quite important. I'll show why, because you want to write reusable code so that you're not repeating yourself. You make a function so that you can run it over all of the pieces of data you have. RN, this is your library of R packages. It's good to keep a separate library of R packages for each project you're doing, because you can run into conflicts between different packages, between their different versions. In fact, I was helping a colleague with that just the, you know, just the other day, that the versions, yeah, like functions, packages, the APIs change over time. So the commands that are used today might not work on that same package from 2016 or whatever. So I consider that quite important. So yeah, more or less the same kind of stuff here. Temporary data I put in its own place. So basically, I thought about these things quite a bit, and so I put in this template. So if you're so inclined, you can take a look around and pick and choose what you might want to incorporate into your own analysis, you know, to help you out. And again, so these are some of the components. These are some tools that I think are highly valuable. Git and GitHub. Docker I mentioned a couple times, and Docker Hub. What is Docker? It's a little complicated. It's they're Linux containers, so it's like a mini operating system. This sounds quite heavy-handed, and it is, but it does work. That you can create a mini operating system for every analysis you do. It sounds kind of crazy, but it's gained popularity in the field. Right. And Docker Hub is a website for hosting your Docker images. And it's quite nice. You can integrate it with GitHub. So what I do here, I make, this is all, you know, GitHub and Docker Hub related stuff, but you can specify a tag. So you specify a certain code, set it to auto build, and it links with your GitHub. And then what I do, I make a release whenever I want to make a new Docker container. And then Docker Hub will make my Docker container. See, you have to match the tag and everything, and it'll make it for you. yeah, if anyone wants to get started, like I said, it is a learning curve to this stuff, but I'm always open for communication if anyone wants to try some of these things. And the value of the Docker file is you specify the packages that you want for your analysis, and also system packages, like Linux system packages. This was a dependency for one of these. So it's by far the most reproducible way to do your analysis. Singularity is very similar to Docker. I use it just as a wraparound Docker. So in high performance computing scenarios, Docker is typically not allowed because it has basically has root access. It has certain privileges that you wouldn't give a computing cluster, you wouldn't give a user to in a shared computing cluster. But Singularity, they've overcome that problem by building containers that don't give you these elevated privileges. And so basically, I've wrote code to wrap around. So it basically uses my Docker image, but it runs it in Singularity. So, right. So using this, I was able to, use my Docker images in the computing clusters at UCL, like the Myriad cluster, which is great because those are very powerful computers, and sometimes you need that kind of power. So Singularity helps you overcome those things. And again, that's in that template. RM, so that's, more package management, but that's at the local level. It's a more simplified way, basically. Cloud storage, I store all my, data that's not code in Google Drive, or now we have Dropbox within UCL, so that's nice. And our Markdown I was mentioning before with my slides, I think that's, yeah, even if just peruse the website, actually, you see some really amazing things in there. I mean, you can take your R analysis and directly make interactive HTMLs that you open in your web browser, which is what I normally do, and make a PDF ready for basically publication. I don't know if, I don't think any journals like accept, well, maybe not at that level, but it's, very clean, presentable documents. So I think it's quite handy. If you're going to code, it saves you time in the end, because then you have your already, instead of copy pasting things into a PowerPoint, I think it's very efficient. This kind of goes along with our Markdown. So I use Zotero to organize my references, and then you can put it in a collection, and then you can export it as BibTeX. And then you can incorporate that into your R Markdown, which I'll show in a sec, so that you automatically get citations. Is that it? Okay, this is almost done here. This is more to showcase, how you can put code in your slideshows. But yeah, so there are multiple places to get your packages from. CRAN is the, most typical, most common. Bioconductor, lots of people here use Bioconductor. This is a specific repository. By repository, I mean like a place where packages are held, software is held, specifically related to R in this case. So Bioconductor has a lot of, bioinformatics related packages. So first you install Bioc Manager using install packages. And then with Bioc Manager, then you install the Bioconductor package you want. And you can also install things directly from GitHub. You just have to install dev tools first. All right, so there's no questions at the moment. Then I'm gonna, move on to an example of, a more relevant analysis. So this is a, RNA-seq analysis at the post-process stage. This is no star alignment or anything like that. So just basic differential expression. And this is just to show an example of how I organize my projects. I've actually updated this since, so I have a slightly different way of organizing this, but this is, generally still relevant. Before getting to that, actually. So I have all this. This looks really, really disgusting. I know. But the reason why I have code like that So that's all part of that R Markdown. This is called YAML, this style of code here. So it doesn't work directly in the terminal, but if I do this, so I get the name of, this is just a really disgusting way, but I think it's the only way to get you know, the name of the project based on the name of the folder. And I do this because I mentioned before, I tried to organize my data so that I can write, you know, one piece of code and then I can just apply it to every data set. So this is, you know, one of those automation things that I like to do. Same thing for setting the date. You can set it to current date, things like that. Where's the, okay, I don't have the bibliography file in this one, but right. So coming back to this, right? So typically in analysis, first you load in the packages you want. I have this line of code here to suppress all the, sometimes it gives like warnings about generally benign warnings, so I block them out. You want to source a specific, you know, file, custom functions, you would do that here. And then I try to, you know, specify, you know, directories. So I try to keep this all at the top so it's easy to edit, you know, the directories that different things will go in. So I think this is, you know, a good way to keep organized, you know, for whatever analysis you're doing. Another thing I like to do that's been very helpful is making cache directories. So whenever I have to generate like an object that takes a long time to compute, there's not an example here, but on another analysis I'll show really soon, I save it as an RDS file, which is, you know, a data file common to R. And this is good, so you don't have to rerun these heavy computations. So I like to programmatically make these cache directories. And so, right, so these are some common problems you'll run into when you're doing, oh, first of all, nope, not what I'm trying to do. Let me clear this out. It's good to, you know, clear your environment and restart if you're bouncing around different projects. I don't think I was, but I'm just in the habit of doing so. So it's very handy. In R Markdown, you can run right in R Markdown. And this command, so this will run all the chunks above this. So it's basically loading in all my packages and things like that. So this is the data file we're going to load in. So it's a RPKM file, which is, so that's like a normalized gene count matrix from RNA-seq data. So again, I'm going to use the Control-Enter to read that in. And so that's in now. So you can take a look. So this is what, you know, a typical, you know, it varies, but this is, you know, what one data set might look like. And so there's some immediate, you know, problems to identify here. This is specific to RNA-seq, so I won't go into, you know, terrible detail, but so these, these genes here, they shouldn't be directly within the matrix. They should actually be as row names. I'm realizing now that I probably could have added an argument here that made it go to row names. So actually, I think the approach I have here is a little, I guess, unnecessary, but gets the job done. So if you can, you know, use specific commands to move things into the row names. This $ is very useful. You can directly call any of the columns within your data, and you can tab. So if you hit the tab key on your keyboard, it'll like auto-complete them. So that stuff helps a lot. And so with those 2 lines of code, so now those are moved to there. So these are the kind of things that as you're doing an R analysis, you're regularly going to run into, typically at the beginning stages. And then typically you get to a certain point where you always want to get to a standardized data structure. And then from there, the analysis tends to get easier in certain respects. It gets difficult in respects of like interpretation. And if you want to run a complex analysis, you know, you got to think about the right way to do it. But there hits a point where you don't have to do as much cleaning. That's typically at the beginning. But if I read in this metadata, so that has a problem here where, see, they use dashes here, but in here they use underscores. So you gotta fix that stuff and use G sub. So this is like routine data cleaning that you want to do. And if you're interested in a certain population, you know, you can pull that out with certain code. And so for figuring out how to do this kind of stuff, again, if you're new, we're very fortunate that Google exists, and Stack Overflow, ResearchGate is good. That's a little more, you know, wet biology, but BioStars, just Google search your problem and you'll find someone that's, you know, dealt with it, and just read other people's analyses on GitHub and whatever. Right, this is interesting over here. These retrieved gene symbols, right? So these are, no, not this. These are not human readable, but they're good because, so these are, I believe they're ensemble IDs, and so they're unique. Problem with gene symbols is that sometimes they're not distinct. You can have like, I guess, two gene, well, every gene has a unique ensemble ID, but a gene could have multiple gene symbols. So so these have a, you know, superiority as far as like a one-to-one match, but it's helpful to convert them for the purposes of if, you know, the human's gonna look at the data in the end. So biomart is one way to do that. And then did I actually put that into the, right? So you can get that kind of stuff. R and Bioconductor is very good for those kind of things. And right, so we don't really have time to go through all of this, but this stuff is, yeah, very interesting. It can get quite complicated using lemma and model matrices. This is kind of like a core tenet of our statistical programming, these model matrices for making your statistical model, basically. And so I'm just gonna say, you know, I recommend reading up on model matrices and factors, you know, if you're gonna use a program that uses those kind of things like lemma, seq, or transcriptomics things, but yeah, general like linear regressions also use the same kind of design matrices. So they're good to know, but I don't think it's within scope of this to go into that. Last thing I'll do, I'm just gonna knit the thing just to show this thing runs pretty quick actually. And you'll see with, after hitting Control-Shift-K, now it's making my fresh R Markdown document. And there you go. You have another one of these complete with plots and everything. And R Markdown is so good for documentation that, you know, you can toggle code on and off. So, you know, you can share this as your final product basically, and they'll know, you know, what, whoever you're sharing it with, they'll know what you've done. So I think that's really important. Right. So this is, I'll just go through this kind of quick. This is just like another demonstration of why I think it's good to, you know, try to not repeat yourself, because so these are two single cell RNA-seq analyses, and the only places where they differ is up here and in the cleaning, like I mentioned before. That's where, you know, you got to fix those problems. But after that, so that's all, you know, standard. This is good, you know, it makes things more comparable, you know, between the things you're analyzing. And so like my cluster pipeline, I think it's good at some point to consider, you know, putting your analyses into a function, because then you can quickly apply it to new data sets. So they have the same cluster pipeline. Wait, why does that look different? Oh, did I just negate what I was saying here? Well, that's interesting. Oh, I see. There was right. So the naming of the genes is okay, slightly different between the two. That makes sense. So it gave like a little warning output. Yeah, so it is the same R markdown code. So right, so I tried to put these things into a utils file, and I shared a utils file with this very handy data table custom. I mean, I could share, you know, any other code if anyone asks, but so this I put into the template that I was saying, that I was mentioning before, and this is useful because you can make data tables that can you can download a CSV, an Excel file, PDF from. So it's quite good. If I come across a, you know, another instance of where I use that, I'll point it out. But right, so that cluster pipeline, it's a long and scary function, but it works and it's very handy now that I have it written. So things to consider. And then of course, you know, if you write something and it works well, then you can share it with the rest of the community. You can consider making a package, and you know, that's very nice. That pushes forward bioinformatics. And right, so I'm currently working on putting, you know, some of this stuff into a package. You can get, you know, very complex your analysis, and been incorporating pathway analysis with trajectories. So I'll be putting that into a package soon. So if anyone's interested, they can try it out on their data. And finally, all right, so this is, yeah, I'm getting to the end of what I want to show here. Oh, real quick. So this is actually running in Docker. I didn't point this out, right? Suddenly now we're running RStudio in my web browser. Whereas before, we were in, this is just a normal, right? Just a normal program, desktop program. So this, I'm running this through Docker. I have like a little web server here, and then, so if you run, I have a function for that, Docker compose up RStudio, and that's in the template. Then you have to put in a little extra code to connect to it, because it's like a remote computer, basically using a server at home. And then what's nice is like you can run all this stuff. You know, I don't have to stress out my own computer. I can outsource it to a remote computer, and I can close my laptop and it'll still be running. I think that, you know, doing those kind of things can be, you know, very helpful and efficient, but it takes some setting up. Well, that's why I hope this template will help. So, right. So I've shared this on GitHub as kind of a simple example, and I tried to, you know, like organize it, you know, so these are kind of the things that you would, you know, tweak. These stuff, you know, it's a little confusing, but if you go through it, it's not as bad as you think, but it's, you know, it's all automated, so you should be able to just use it. And this is a very simple example. It's not a true differential gene analysis because I didn't want to include all that bulk there. It's just, I did the analysis. There's this geo to R thing on the geo database of, I don't think it's just transcriptomics data, might be, but anyways, I did the analysis online, and I just took the data file so that I can just sort, because I wanted to keep this simple. So yeah, this is some basic code that could be, you know, useful to just how to sort different things. And then that's all this stuff here. And, you know, I put instructions here. And so, yeah, I'm hoping, you know, if anyone, you know, wants to try it, you know, happy to help. And I think that about, I don't even know why I have this open. Oh, this is connected to Myriad. Yeah. So is it? No, I don't remember why I have this open. I think this is maybe me running Docker locally. I don't know. But yeah, that about sums it up. So template for use and some things to think about when it comes to project structure, but, you know, also try not to get too bogged down on it. At the end of the day, you know, we're doing biological analysis, but we don't want to build up technical depth. So, you know, at a critical point, now it's slowing you down because you're running into issues because you didn't plan it out in the beginning. Yeah, that's it. If anyone, yeah, if anyone has any specific questions, feel free to ask.
Hi.
Hello.
Hear me?
Yep.
Oh,
I'm
cool.
trying to get my video back on. Sorry, just give me one moment trying to find, here it is, Zoom. It's my participants. Oh, here. Okay. Oh, well, it's all right. Yeah, you have a question?
Yeah, when you were going through the first kind of example functions you were using earlier, are they
Yeah.
all in RStudio, or do you have to install any packages to be able to run those?
Oh, yeah, those require packages, yeah. Like, so you're talking about like these big chunky ones, right? I suppose.
Yeah, but also even the ones you ran earlier on, actually, or the ones you
Uh,
were showing earlier on.
right. Depends on how earlier on, I suppose. So like these here, these
Yeah.
were all, yeah, so these are all, yeah, built within R. I didn't have
Okay.
to install anything extra. Yeah,
Cool.
everything here you should be able to just run on a fresh installation of R.